in your eyes. Okay. Good morning, everyone. Let's see. Audio's working. Video should be working. Desktop's working. Everything should be working. Can we all hear me? Let's get a sign of life. Hello, 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 hello. Fantastic. Okay, thank you all so much. I know one of the biggest asks of a course like this is to get everyone up at 9 a.m. So the fact that there are almost 400 people here tuning in live is fantastic. So first of all, again, welcome to COMP1511. My name is Dr. Jay Cronzella. Hopefully you watched the little video that I put out a few days ago. I just want to say how excited I am to teach and to work with you all over the next 10 weeks. We're going to do so much in the next 10 weeks. It's a really exciting time. Yeah, I'm just so excited to work with you. This course, I think, is one of the most important courses you will take, not because it's challenging or because it's difficult or anything like that, but just because of how important it is and how much potential it has to change the way that you think about programming and think about even the world and what you will go on to study and do. You're going to do amazing things, and I'm so excited to be just a little part of that whole process. So let's get the lecture slides up. And now, again, it's the first lecture, so you have to bear with me a little bit because there's a lot of, as you can sort of imagine, there's a lot of systems. But this is looking pretty good, actually. So welcome to COMP151 Lecture 1. Let's see, where am I? Presenter notes, here we go. Before we start, I just want to show my respects and acknowledge the Bedegal people and elders past and present who are traditional custodians of the land on which this lecture is taking place. And excuse me for having to read that. I've only recently moved to Sydney, so we have a different acknowledgement of country back in Melbourne. So I just had to make sure I got that correct. Okay, before we get started, oops, here we go. What are we going to do today? We're going to introduce the course. I'm going to introduce myself. Really importantly, I'm going to introduce the course administration team and the teaching team in general. As you can already imagine, so there are some moderators in the chat. That's obviously not me because I'm talking to you. So you've probably already got an understanding and beginning to understand that we've got such a large support and teaching team, not just the course administrators, the tutors, but even behind the scenes in the university, in the school. So many people work really hard to get a course like COMP151 to run this smoothly. So we're going to talk about that a little bit. And then we're going to talk about the actual course. How do we approach programming for the first time? Why is this course important? What is programming? What is a computer? What is a machine? Fundamental questions, philosophical questions sometimes, that's going to shape this course. Okay. So, let me introduce myself first. I'm Jay Cronzella, like I mentioned. I'm the lecturer in charge of this course, sometimes called the course convener. So what does that actually mean? There's a lot of words, a lot of terms, a lot of roles, a lot of people. What does this actually mean? So I'm the person in charge of the delivery of COMP151 for 22T2. So I'm an academic in the School of Computer Science and Engineering. I'm a lecturer, and this term I'm tasked with such an exciting opportunity to teach COMP1511. A bit about my background. Why am I here teaching this course and not some other course? There's a few reasons. First of all, I am, always will be, and love software engineering. I worked in industry for a few years, working on some amazing projects spanning a huge range from internal tooling for development teams to systems used in medical trauma reaction systems and things like that. And specifically, though, my actual PhD research is on introductory computing education. So I look at literature, I produce literature studying the field of how humans learn programming for the first time. Why is it so difficult? Why do so many people have anxieties about it? So many people struggle. What's the state of the art? What works? What doesn't work? This is what I sort of do in my free time. So as you can imagine, it aligns so well with what I'm doing here with you all today, which is teaching you programming, hopefully sometimes, maybe for the first time. And because I am really interested in programming education, I work on a lot of educational systems to support and facilitate education. So some of those you won't see throughout this term, but it's just to show you some of my interests. Okay. Then we have this amazing course administration team. So I can't teach 1,000 students for myself. It's not possible, and I don't want to. The sort of biggest sort of administration support team, and it's not administration, it goes way beyond that. So we've got Tom, and then I think everyone is in the chat actually. Tom, Shrey, Ben, and Tammy. I think all 4 of these amazing people are in the chat right now. Say hello if you are. Say hello to them. I really can't stress enough, these people have been involved in COMP1511 longer than I have. They know this course inside and out. They know the course infrastructure inside and out. But beyond that, they are some of the most proactive, intelligent people I've ever worked with in any environment. So I'm so excited that they're here supporting us, all myself and you, in COMP1511. So please, when you see things happening, remember it's a team effort, and I hope you get to interact with these people. On top of that, we have a huge number, hopefully it's this slide, of tutors. I can't begin to list them all. Here is just some of them. Some shout outs. We've got Noah in the chat who's helping to moderate the Tuesday lecture. You can meet the team by scanning this QR code and seeing a description of every single person. Maybe try and pick out your tutor. I think, there's 30, 35 tutors this term. Each one of these people are handpicked from, Shay might know the number, and Tom, how many applicants do we get each term to tutor this course? It's a huge number. And we really want to make sure that we pick the best people to support you in your tutorials and labs. So each term we get 150 to 170 applicants 3 times a year. They're all such amazing people. And no matter who you get, you're really lucky to be working with that tutor. Okay. So there's a lot of administration information associated with any university course, and especially COMP1511. For us, this is the website that you need to go to access that. So you can scan the QR code right now. Hopefully you've already visited this page. I think I can open this link. Maybe. Maybe not. Whoops. It doesn't want me to, but it doesn't matter. I can just go to it here. Oh, don't do it? Okay, yep. I didn't realize that, yep, okay, the page might be down temporarily. Maybe at the end of the lecture we'll come back and I'll run you through this course website. All right, Shrey, get busy, fix the website. Thank you. All right, some important stuff. I would love to just get into programming, but we have to go over some really important administration. So there's a few different teams or people you can reach out to if you have an issue. I've mentioned it's a big course, but that doesn't mean you're a number in the sea of students that we don't care about. And this is the reason why we have so many, we just want to make sure that you do get the help you need. And part of that is making sure that you communicate to the right channel. So for any administrative related issue, let's say you're sick and you can't make your tutorial, you don't understand something in the course administration page, any administrative, non-programming, non-technical issue, you can email ces1511@csc.unsw.edu That's this email over here. This, to be sort of transparent, goes to myself and the course administration team. So those 4 people you saw on the previous slide. And one of us will answer that. For any enrollment specific issues, so you need to switch your tutorial time permanently, or I don't know, something's kicked you out, whatever it is, we do not handle any enrollment related issues. You can contact the UNSW nucleus for those specific issues. And finally, if you have an equitable learning plan in place, which I know a few of you do, please directly email those to me at jake.renzella@unsw.edu.au, and that'll only be visible by me, so I can log it on our records and make sure that we make adjustments to facilitate whatever it is we need to. Okay? All right, so then what happens, and this will be 99% of the time, what happens when you have questions or problems on the actual course content, so the programming that we're doing? Well, one of the best things, one of the best resources that you should use is the course forum. And that is something I can show. Okay, here's the course forum. Hopefully you've all seen this. You can see Shrey has announced that the lecture's going live. You can see we've had 220 posts already just in the introductions thread, and I've done my best to respond to some of those. But you can see here that students have already been posting questions. You know, I'm getting some error when I'm doing this, or I'm having some issue when I do this. The forum should be the first place you go to, I would say, when you have a course-related question. Why is the forum the best place to go? Well, there's a larger number of people monitoring the forum, so they can respond to you quicker. Secondly, when you get a response to a question, all other students can read that response, and you'll actually be sort of, crowdsourcing and helping other people out with their problems. So the course forum should be your first port of call. If anyone has studied previously at another institution, not UNSW, maybe you've got this idea in your mind that course forums are these things that get ignored by the teaching team, and questions go unanswered for weeks and they're kind of useless. Just to sort of drive the point, maybe Shrey or Tom or someone how many posts were made in 22 T1, and how many were answered? The number will come up in a moment. Shrey can get the number. Awesome. This is one of the most well-resourced machines I've ever seen. Thousands of posts. Every single one was responded to with a solution or a response within a day, and oftentimes actually a lot less. We'll drop the keyboard deets after the main content. How's that? All right. Of course, then you have your weekly tutorials and labs, or the tut labs. That's sort of one thing. I saw someone in the chat mention earlier that, is this going to be the tut lab flower stuff? No, the lectures are completely different from the tut labs, so make sure you attend both. But of course, when you're in your tut lab, you've got an amazing tutor and you've got an amazing lab assistant that you can ask questions, programming questions or life advice, fashion advice, whatever it is. You can speak to them. That's what you're paying for. That's what they're paid to be there for. And you can get help from that tutor when you're in that scheduled help session, tutorial session. And then finally, we have the help sessions. The help sessions is another amazing resource. This is a drop-in service. So basically from when they start, which will be about week 3, there will be a schedule put out. It's pretty detailed, pretty well resourced. And if you're stuck on something and the forum's not cutting it, and you've got another week until your tutor, you can drop into the call, wait in a queue. Please do expect there will be a queue. There's a lot of students that need help, but we will, scale up the resourcing of it. And you can get one-on-one ad hoc support or help from a COMP1511 tutor, okay? And that's the help sessions. And we have some other systems around that, but nothing you really sort of need to worry about too soon. Okay. Of course, it's a custom keyboard, guys. Don't besmirch my good name. Okay. So what is COMP1511? Likely it is your introduction to programming. This is where the journey starts. I can't sort of stress enough how exciting it is to be here in this moment right now at the beginning of something beautiful. This equivalent of this course it made me change my degree. It made me change what I wanted to do as a career, which was then to go into software engineering and then eventually go into software engineering academia. But it was all because of this course. So I feel like I have a lot of pressure actually to make this course as amazing as it was for me, for all of you, and I'm sure we'll do that because we have such an amazing team behind it. But talking about the actual COMP1511 course, what's it all about? There's a lot of different approaches to teaching introductory programming. And I can honestly say, unbiased, that the approach that UNSW takes, I think, is the right approach for what we're trying to do, which is to produce some of the world's best computer scientists, software engineers, thinkers at all. So the core thing to understand, and we're going to revisit this a lot, is that computers are unintelligent. They are extremely efficient, they're extremely fast, they can do things really well, but they are these machines that are completely unintelligent. And that means that they can only follow very specific instructions that are provided to them. Those instructions need to be written or laid out by a programmer, by a human. And so what programming is being able to produce these instructions that the computer can execute, and to execute it better than we could execute it, of course, and produce some sort of result. So it's a mix of communication with a machine, problem-solving thinking. It's a practical skill. It's a philosophical skill sometimes. You have the way you think about languages and programming. But at the very core of it, you have a machine that executes instructions, and our job is to teach you how you can think about writing those instructions. So the course format, so we assume no prior knowledge of programming, zero programming experience. Many of you already have some experience, and that's fantastic. Maybe that experience will just help you in COMP1511. Maybe it'll actually be better for you to sort of disregard what you know or what you think you know. But the really exciting idea is that I know a lot of people, and I've looked at the literature on this, are very anxious about programming, are very nervous about programming. Maybe you've tried in the past, and this happened to me. I remember picking up a book, I think it was Introduction to Programming in C++, and I was reading it on my own, and I didn't get very far, and I was like, well, this is hard, maybe I'm not cut out for this. That's normal. Programming is a difficult skill to pick up for the first time, but the way we're going to present it to you is such that you're going to learn, and it's going to be amazing. But it's normal to feel that anxiety. So all I want to make sure is clear that we don't expect you to know anything about programming, and we're going to take you from the beginning. So the lectures, what are we doing right now? Hopefully, you're here. So they're streamed online via YouTube Live, which you're all tuning into right now. Tuesday, 9 a.m., that's where we are today, and then tomorrow at 3 p.m. on Wednesdays. With the exception of week 6. Week 6 is flex week, so there's no formal lectures. But I'm thinking about some bonus content, maybe people we can bring on to do a guest lecture or something like that in week 6, but that's sort of just optional. If you have a question, you can ask it in the live chat, which you're all doing, but most of you are just talking about my keyboard. But you can ask any questions there. We have people, we have moderators to respond to your questions as they come up. And super important, especially in the live chat, please be respectful of others. I know that, especially coming off the pandemic, live stream, Twitch, YouTube live culture, I understand it. But please keep in mind that even though we're on YouTube Live and it seems like one of these environments, it's very different, right? This is a tailored, specific live stream to a specific small group of people, and respect in everything you do at UNSW is of the utmost importance. So please be kind to each other, be kind to the teaching team, be kind to me, please. But more importantly, be kind to each other. Everyone's here to learn. This isn't a Twitch stream with 50,000 people, where it doesn't really, your voice gets lost in the chat, right? We read everything you say for good or for bad. So I just wanted to sort of stress that. But I think you all sort of understand that anyway. What are we going to talk about? We'll talk about some theory, what it is that we're trying to understand. Oh, you can post a poll. That's completely fine. Compliments. Just be respectful of each other. We will do some demonstrations, live coding. That's always really fun. Problem solving. How do we know what to code? How do we know what to implement? We'll talk about some other stuff outside of programming, some sort of philosophy about programming languages, software engineering, things like that. We've got all the lecture slides, which I've put a link there. I don't know if the website's fixed yet, but all the lecture PDFs will be available before the lecture is live, hopefully. But you don't really need these slides today anyway, so you're okay. And of course, the lecture recordings will be available in the YouTube playlist that we will link via the course website. So everything's available. Everything's rewatchable. If there's anything that you think we've missed, let us know. Yeah. Okay. Then you've got your tutorials, your 1 hour, 1 hour? I guess, yeah, they're 1 hour. They're 3 hours, but the first hour is the tutorial. Excuse me. I guess, so does that mean I can show the course website now? Oh, well, okay, yep. 4 people have linked it simultaneously in the chat. That's awesome. I can show it. I just wanted to quickly show sort of how to navigate it. So we don't know what's going on with this T, but you can ignore it. So this is the course website. Pretty, as all programmers, what we have this sort of, we do things and we build our own solutions to it. So this course website is built specifically for COMP1511. And so, spill the tea. Don't know what's going on with it. So the lectures, so for example, when it's Tuesday, 9 a.m., you can just click this button. I'm not going to do it. And it'll open up the lecture, the live lecture. You can view the lecture code here in this beautiful directory. That's hard linked to week 1. Yeah, I suppose that's fine. So any code I write today in the lecture in real time will be updated on this page. I know the page doesn't look fantastic, but it's a live directory. So literally, as I click save, as I type save, the code will live update. They'll also, I think this is the lecture PDFs. T links to H. Anyway, something's going wrong there. I think that's meant to be the lecture PDFs. We'll fix that up. And then your tutorial activities, your lab problems, some cheat sheets, setting up guides, style guides. It's everything you need is here. The link to the forum is here. So click the link. Something about the forum that's really important. We're getting a lot of emails where students are saying they can't access the forum. It's super, super important that when you sign in, use your ZID at unsw.edu.au, no .ad in between. So z blah, 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 blah at unsw.edu.au. If you sign in with that correct email, it should let you in. If it's not working, just email the course email, comp1511, cs1511 at edu. But it's important that you use the correct ZIT. Okay. And then the timetable is also here as well, with all the details. You can see how many tutorials there are on where and how to attend the tutorials. Okay, so that's the course website. So you attend your weekly tutorials. Some of you have already attended your weekly tutorial yesterday. It's always really challenging when the first tutorial occurs before the lecture, but I'm sure your tutors know exactly what they're doing and you had a great time. Most of the tutorials will fall after today, which is a little bit better. And the aim of the tutorials is to get support on a smaller scale, getting your hands dirty, solving problems, writing code in a community with about 20 to 25 other students. They're a good place for interactive learning where you'll have time to discuss and work through your problems. These are occurring online and face-to-face. Once again, all of the allocation and the scheduling is not handled by us. So if you're in an online tutorial, you go to your online tutorial, which is held on Teams. You should have already been added, or maybe in the process of being added to these teams, but it'll be pretty simple. Please, if you are in an online tutorial, turn on your camera because it really helps. It really helps us, your tutor, feel connected with you and feel like what they're saying is working and landing and things like that. We understand that not always you can do that, and that's okay. But if you can, please do it. And we love seeing pets make an appearance. We don't mind a bit of chaos. But yeah. A really good question's come in the chat from Will. What should we do if we're enrolled in a face-to-face tutorial but can't make it because we're isolating? I think I've got this information on a slide coming up. It's really important. Obviously, do not come to UNSW. Do not come to your tutorial. What do you do instead? Really simple. You go to the course website. You go to the timetable. Whoops. You find an online tutorial at a time that you can attend, and you can just attend it. We will update this page with links so that you can actually join the team, the Microsoft team, and you just attend an online tutorial that week. That's it. Yeah, and it doesn't have to be COVID isolation. It can be if you're sick, if you're not well, anything like that. You just find an online tutorial at a time that you can make it and you attend it. There's you can see there's a few on different days as well. Friday, there was one yesterday, there's one tomorrow. There's a bunch. So you just attend an online tutorial for that week. It might be nice to give the tutor that you can see who the tutor and the lab assist here. Give them a heads up, but even that, it's not that important. But it is, I will say, of course, if you're isolating, if you're unwell, go online. It's important to go to your tutorial for logistics and things like that, but because it's important to build a relationship with your tutor. You want your tutor to remember you, to know you, to understand you and what you're working on. So only go if you're, sick or isolating for one or 2 weeks maybe. If it's a longer term change, you need to email Nucleus and switch the allocation. Okay? So this is the tutorial. Immediately following the tutorial, so really it's 1 3-hour block. Okay, so that's the tutorial, and then immediately follows the lab. What follows is the lab. It's much more sort of working in groups, writing code, solving problems together. So in the tutorial, you might be presented or guided with some activities that you're still working on, but the lab's really all about getting your hands dirty. You can have one-on-one conversations with your tutors, and this is where you can get started working on the weekly lab problem sets, and we'll talk more about the assessment structure in a moment, but overall in the course, these count for 15% of your total mark. They're marked automatically, so we have some auto markers. So you submit your code, and they auto mark that code, and that contributes part of your mark. And of course, your tutor and your lab assistant will take you through that process. There are some challenge exercises as well. Some of them are pretty tough. They're really good. They're not necessary though, and they're not worth any core marks. Maybe some bonus marks, but not even all of them are worth bonus marks, I think. And once again, just like the lectures, that the tutes and labs do not run in week 6. So week 6 is a non-teaching week. Oop, I feel like I already showed that slide. Okay. Assignments. So I just mentioned we had the 15% lab marks. Then we have the major assignments. There's 3 assignments in this course. Actually, the first one starts this week, but don't stress about it. I'll explain what's going on there. One of the biggest things we noticed in the past was that students who started the assignments early on time did well. Students who started late did not do well. So what we've done, we did this last term for the first time and it worked really, really well. We've added a really small assignment this week to really push you and get you doing the right things with the assignments. But what's really important with sort of all your university work is that you start on time and get the help you need. So assignments are individual. You work on them yourselves. They span a few weeks. Okay. They test how well you can apply the theory that we've already covered in the course, things that you've already learnt, nothing new, nothing from the future. And there's 3 assignments. Assignment 0 starts this week. It's due in week 4. And it's only worth 5% of the mark. So it's really small. It's a really sort of simple assignment to get you up and going with the tools and the editing environment and all of that. Assignment 1, these are the due dates, not the start dates. It's due in week 7. It's worth 15% of the mark. And assignment 2 is worth 25% of the mark. That late penalty figure is not correct. It's not 1% per hour. It's actually less. This course is using the UNSW policy. I think it's 5% a day? Can someone in the chat remind me? But basically, your mark will reduce every day for 5 days that the assignment is late. Yeah, 0.2% per hour. So it's a little bit more flexible, I suppose, this term. Okay. Help sessions, okay. So we spoke briefly about these. These are where you can drop in and get help on a one-to-one sort of drop-in, drop-out service. We will hold these on Microsoft Teams. You'll be added to the course-wide team in a few weeks when we're ready to do that. You will get a one-on-one consultation with a COMP1511 tutor. It's a time for you to ask individual questions or get help with specific problems. There'll be a schedule on the course website soon. Please keep in mind, these get extremely busy, especially around deadlines. That's why it's so important to start early and, get help when you come across it. And hopefully that's a bit earlier than when everyone else is sort of getting to it. We do have a FastPass system sort of modeled around the whole Disney FastPass system, where you'll have an opportunity to get a FastPass sort of ticket to help you get help at these busy help sessions a bit quicker. But they're limited. Obviously, we can't give them to everyone, but it is fair. Like everyone will be available to get 1 or 2 or something like that. There's some discussions around the late submission percentage. It changed literally last night, so some of the material's a bit outdated, but it really recently changed. So we'll get all of that sorted. Don't worry. Yeah, but with this FastPass, Jaden, you don't have to pay for it, so that's nice. And then finally, we have the final take-home open book exam. I know exams are scary. This is not designed to be a scary exam. You have a long time to do it, about 3 to 5 hours. It's not a 5-hour exam. You just have 5 hours, so it shouldn't actually take you that long. You'll be given a series of problems that you will solve in C. We'll talk about what C is in a moment. And you'll be expected to read some code and communicate to us your understanding of it. And there'll also be some questions covering sort of conceptual programming ideas. Parts of the exam are competency hurdles. What does this mean? It means that you can't completely fail the exam and pass the course. It doesn't mean you can, there's bonus questions even on the exam that you don't have to pass. But the really core concepts of the exam are a hurdle. The exam is online on your computer, so you're not writing code on paper, although that's how I did my programming exams. Maybe one day that'll come back. And these questions must be answered correctly. Wow. Cool. Okay. Let's not focus or stress about the exam just yet. So let's have a look at an overview. The labs are worth 15%. The assignments are worth, 45% in total? And the exam is worth 40%. And that's your final breakdown of the COMP1511 assessment structure. So you must score at least a 50 out of 100 overall to pass the course. And there's some, we're sort of trying to be transparent on what exactly will get assessed in the assignments and the exams. All of that will be really clear. I just want to stress one thing with this assessment. If you come to your tutorials, if you attend the lecture, if you do the labs, if you're engaged, I promise you, you are going to do great in COMP1511. This is not a course where we're marking on a bell curve. We don't have a minimum number of students we need to fail. We want you all to pass. And if you look at the data historically, if you're engaged, 99% of you will pass if you're an engaged student. The students that don't pass are people who maybe dropped the course and didn't tell us, or something came up, and that's completely fine. But it's worth mentioning that if something's come up that's out of your control, this doesn't necessarily mean that you will, fail. There are support structures. We'll talk a bit about that in a moment. But there's ELP, there's special consideration. There's ways that you can get help when the reason for you not doing well is out of your control. But what's really important on that is that you are proactive. Okay? So you're all going to pass the course. I'm certain of it. Here we go, special considerations. Any issues that make it difficult for you to study. So if you get COVID and it's not doing too well and you're out of action for 2 weeks, apply for special consideration. If familial issues come up or personal issues come up that's distracting you from studying, apply for special considerations. I know Shrey and the course admins and Tammy and Noah might give some other examples of when you can apply for special consideration. It's managed by the university. It's all kept private. It's all confidential. Only I read it if I need to, if I need to adjust marks. I don't even need to read all the details. And you might already know that you should get some special considerations already. You can apply for them already. And then we also have ELP plans, equitable learning plans. These are when you have sort of longer term sort of issues, distractions, circumstances that might mean you need more rigorous support. We are more than happy to cater for you. In the past, when I've taught these sort of courses, I've had students with vision problems, hearing problems, a huge range. I had a student once who was deployed on a Navy ship and only had internet for 1 week every 4 weeks, for example. That's a good example when you might need an ELP plan. And with that ELP plan, I was able to give that student 4 weeks worth of content at each time, and they did amazing in the course. So these longer term problems, yeah, and they still pass. So you have no excuses, guys. No. So anything like that, you can apply for an ELP plan. I think I'll get someone to put the ELP link in the chat. Okay, it's worth noting, yeah, if someone's just mentioned a wait list. These are managed by the university, not by the School of Computer Science and Engineering. There may be a delay in getting them approved or something like that, but that does fall a little bit out of our hands. Okay. If, let's say, you can't sit the final exam because something has come up, that's also completely okay. We have supplementary assessments. So for example, a supplementary exam can be offered that you'll take at a later date. But let's not worry too much about this. All right, code of conduct. Code of conduct. I spoke briefly about this earlier. You are a university student. You might be on the YouTube live chat with a fake name or something like that. That's completely okay. But in the tutorials, in the labs, in the lecture, you are a university student. You have associated yourself with the university, and there is a policy that you've agreed to conduct yourself according to. So one rule that we really want to push in COMP1511, and this is not going to impact almost any of you, but you will not hinder anyone else's learning. I know that if a course admin or a tutor, or even if other students see something like this happening, and it doesn't happen often, they're going to let me know, and we are going to deal with it properly. So if you feel like there is something that's hindering your learning, and it could be so many things. It could be the way someone else has acted in your tutorial or your lab, or even online, social media, a Discord, and that's related to COMP1511. So discrimination, inappropriate behavior, harassment, bullying, aggression, sexual harassment, not respecting your privacy. If you see this or this happens to you, it's not okay, and we want you to, we want you to speak up if you can, if it's safe to do so, of course. There's so many channels. In a few slides, I've got a page with who to reach out to if something happens. But I just want to really stress, because it's important to me, that any of this behavior, if we see it, it's not okay, and we will take action on it appropriately. Plagiarism. Okay, we've got to do it. We've got to talk about it. I got to stretch. Let me. It's one of the things that absolutely devastates a lecturer is when we see plagiarism or academic misconduct. I know you've probably done some Moodle course on plagiarism or something like that. But let's talk about what plagiarism is and what it isn't. So some people are asking about Stack Overflow, for example. So plagiarism is the presentation of someone else's work or ideas as if they were your own. So there's an element of hiding the origin of the work. Any kind of cheating on your own for this course will incur penalties, and we have details in the course outline. Collaboration on individual assessments, like the assignments, is considered plagiarism. So what is the difference between something like Stack Overflow and something like collaboration with other students and plagiarism? So discussion of solutions and algorithms is completely fine. We encourage it. Using the internet like Stack Overflow is a useful resource. I mean, I tell you, when I worked, and I still do software work in industry, we live on Stack Overflow and Google and GitHub issues and all of these things. And that's completely fine. But one thing that's not fine, for a number of reasons, both pedagogical and ethically, it's that you don't just copy a solution and pretend that it's your own solution. If you do refer to some solution made by someone else, which is completely okay, I do it all the time, you credit your source. So you just have to chuck a line in the source code, a comment that just says that, hey, I took this from this website, it was authored by this person. And that's completely okay. Well, yeah, Jaden's mentioned that programmers always copy and paste on Stack Overflow. Sure. Usually we actually, adapt to what we see on Stack Overflow. And sometimes we do copy it line for line, but still we will put a reference to say that this is taken from somewhere else. Your submissions are entirely your own work. I believe that inherently we know the difference between plagiarism and collaboration. You know when you're doing something wrong. Part of my PhD research is investigating plagiarism and contract cheating in introductory programming. I've seen all of the websites that say, we'll do your coding assignments for you, we'll do this for you. It's not plagiarism because it's original work. All I'm going to say on this is that if you think you're doing something wrong, or you know deep down in your gut that you are doing something wrong, don't do it. Just come to us and reach out for help, and we will help you do it the right way. The only other thing I'll say on this is that we have some really sophisticated tools to detect. Plagiarism is actually very easy to detect in code. And if you edit the name of some variables or the name of some, you change things around a little bit and you think, yeah, this looks different. Actually, no. From the perspective of a machine analyzing your code, it's actually still exactly the same. We have very sophisticated tools to detect plagiarism, and we even have some tools to detect contract cheating. And if you want to know more about how that works, you can go read my PhD thesis. But my point is that we are looking for it. It does happen, especially in online courses. No, we're not assuming you're all doing it. We are taking a good faith approach, but just be aware of it. What happens if you do get plagiarized and get caught? At best, you'll lose marks for that particular assessment item. Okay, that makes sense. At worst, you'll be asked to leave UNSW. Probably won't happen for COMP1511, but it's possible. Even worse, you won't learn what you paid all this money in time to learn. I understand universities in all of you are probably very grade-driven students. You did well in high school or whatever it is you've come from, and you want to do well in university. And part of doing well in university is getting a good grade. I understand why that might motivate you to sort of artificially circumvent the system to get a good grade. However, what you're really paying money for in this course is not a grade, it's to learn. Especially in computing, where some of the best programmers in the world don't have university degrees. It's not necessary to get a good mark to be the best engineer or the best programmer. Or the best whatever it is that you're studying. What's important is that you know your stuff. This is what industry looks for. More and more industry don't really care about grades. They care about what you know. And so what that means, what you should be focusing on in this course is learning. All right. I hate talking about that stuff. Okay. Once again, as a brief overview, course webpage, course forum, the recorded lectures, one-on-one help, who to reach out to for more serious issues, who to reach out to for an ELP plan. Go and view these PDF slides after the lecture, download them if you need to, and access all the links. Within a week or two, I know there's a lot of information we're dumping. Within a week or two, this will all be really simple. You'll know what to do. You'll be okay. Okay, something that I really want to end the first half of the lecture on. UNSW has a huge range of support structures and systems and tools for you that is included in your study at UNSW. So you're paying for these services in a way is something you can think about. And I want to run through because it's so important to me that you are all in an environment where the number one thing you can optimize for is your learning. And what that means is you need to feel safe, feel like you're in an environment where you can learn. Okay, so let's start at the bottom. So special considerations, we spoke about that. Really simple. You just view this URL and you can read about if you're eligible and how to apply for special consideration. If you're coming up against issues regarding to, academic study skills, maybe you need a peer mentor or something like that, there's a website, a UNSW website called Skills, with a lot of information and resources on this. Then we have the equitable learning services, so the equitable learning plan that I mentioned. So if you need to manage anything that affects your studies in the longer term, health conditions, maybe you're going in and out of hospital, maybe you're driving a family member to hospital all the time. So anything like that, please apply for an ELP plan. So we are aware of it. And it might not be that we do anything different. It might be that we make some small changes, anything like that. Report, okay, then we're getting a little bit more seriously, and something that really is I want to take very seriously. Reporting sexual harassment or sexual assault. Again, I hope this never happens to anyone. If you see something, if you experience something, or anything like that, UNSW takes it very seriously. We take it very seriously. If you're not sure what to do and you're panicking or anything like that, you can always contact me privately at jake.ranzella@unsw.edu.au. No one else reads that email address except for me. However, if you don't want to contact me, you want to just report it, you can report anonymously via this portal, edi.unsw.edu.au/sexual misconduct. Again, we'll make sure that we fix all make sure that these PDFs are available, and that you can just, you can bookmark these websites now anyway, really. So the sexual misconduct, there's a portal there for reporting instances. There's information there on how to get help or anything like that. Moving up again, university life pressures, so financial pressures, visa issues, accommodation issues, anything like that. There's a couple links there. Indigenous student support. You can click these links when we make the PDF available. And then finally, if you're in sort of immediate, 24-hour surveillance, you can call this number 24 hours. After hours mental health support, there's a phone number there. You can contact 5 till 9. Okay, that's 5 p.m. So that's like during the night. And there's UNSW specific counselling. So you have telehealth counselling. It's included in your studies, and there's a Mind Hub resource. You might think I've spent a lot of time on this slide, but for a lot of COMP1511 students, this might be the first thing you're doing outside of the high school environment, which is a really exciting thing. It's a really exciting time, but there's a lot of pressures associated with that. We're going to fix these PDF. Can we not just... I'll fix it in the break. In a few minutes, the slides will be available. I apologize about that. It's the first time you're doing something maybe outside of high school, or maybe you're returning to university and it's an unusual environment. What I really want to stress is that you can always come to me personally and do not feel like, oh, I don't want to bother Jake, he's got 900 students. No, that's not how I see it. I don't think enough people come to me with these sort of issues, but you don't have to come to me if you're not comfortable. You can go to one of these portals. Everyone's amazing. Everyone's professional. You can go to your tutor even if you feel like that's something you're more comfortable with, or anything like that. So, if it's just a one-off tutorial, Nicholas, don't sort of worry about that. Like I mentioned with if you're isolating, you can just attend an online tutorial that week. If it's a one-off, don't stress. Okay. Look at that. It's 9:59 a.m. It's exactly halfway through the lecture, which is just a testament to how well rehearsed I have these slides. So it's time to stretch. It's mid lecture break. We have a little sort of challenge question here that you can all discuss in the chat. Suppose you have to look this cliche question. Oh, thank you. Now I got to change the question. No, time to stretch. I'm going to make a coffee. So if you read my introduction post, I'm I'm both Italian and I'm from Melbourne. So as you can imagine, my veins are just coursing with caffeine. My camera's in the way. How's that? So I'm going to make a coffee. But for those of you going to stick around, Melbourne represent 100%. Suppose you have two buckets. One of these is 3 litres. One of these is 5 litres. How could you measure exactly 4 litres using only these 2 buckets and as much extra water as you need? So while I get a coffee, I expect to see the answer. I'm not giving any extra clarifications. That's not my job. I'll come back. We'll come back at maybe 5 to 10 past, and we'll discuss and then get started with some actual coding. How exciting! All right, I'll see you all very shortly. I'm back. I've got my coffee. Espresso. There's so many comments. Use your mouth. Oh my goodness. This is a Diophantine equation. I have no idea what that is. Awesome. This is my favorite. Fill both buckets and pour the 8 liters into your mouth and spit out into the 5-liter jug. Oh, that's excellent. There's sort of a few ways that we can tackle this, this problem or this solution. I think what I want to get across to you is that, first of all, there is no single solution to really any problem. There's very few sets of problems that have a single solution. And really, Daniel's answer, while it was a joke, fill both the buckets and pour the 8 liters into your mouth and spit out half into a 5-liter jug. We know sort of intuitively that this is a joke, or, this isn't possible. But in abstract problem solving, in computing, there is no reason why there is no definition or a specification that says the maximum capacity of a human mouth, right? There is no reason why this is not a possible solution in an abstract computing environment. So what are we talking about here? Well, what are the constraints provided to us on our system? Unless part of this question specified the maximum capacity of the human mouth, there is nothing wrong with Daniel's answer. So this is both the beauty and I think the challenge of thinking about problems computationally, is that there are really very few sort of these naturalistic physical constraints applied to us when we're solving problems. And so problems, the challenge in solving problems, and the reason why computer scientists have had such a hard time writing programs that can automatically solve humanistic problems, is because we have to specify and understand all the constraints very well. So Daniel will be replacing me as the lecturer for COMP1511, exactly. The other thing we need to think about is that there's multiple ways to solve a problem. I can give a problem. Someone asked earlier, what's the difference between plagiarizing and just coming up with the same solution as someone else? There is an infinite, or not infinite, but there are so many ways to solve problems that it's very unlikely that will happen. Okay. All right. Now I'm super excited. Let me move my camera back. In fact, this is really annoying me. I'm going to be really pedantic here. This was meant to be like this. All right. In the second half of the lecture today, we're talking about computing, programming, the elements of a machine, of a computer. What is a computer? A tool, a machine, the love of my life. Like many of you, or maybe like some of you, not all of you don't have to, there is some innate connection that we have with these mystical and magical machines. But what I want you to come away from COMP1511 is to understand that these machines are not magical. They are very simple, actually. There's only a very few amount of things a computer can do, a CPU can do. What's amazing, I think, and this is what I've come to learn over the years, is that what's amazing is actually what humans have managed to get computers to do over actually a very small amount of time. In this course, we use the C programming language developed, I think, by Brian Kernighan at Bell Labs in America in the 50s and 60s. Brian Kernighan is still around. He still teaches at, I think, maybe Princeton or some university in America. Computing we're babies. And yet look at the amazing things that we can do. And they're amazing because of what humans have managed to get a machine to do. So what is a computer? It's the ultimate tool in its ability to be reconfigured for different purposes. It's a generic machine. Before sort of Alan Turing, started on building these machines, we've in the industrial age, we had lots of machines, and they all sort of did one or two things very well. A computer is amazing because it can do so many different types of. Oh, Dennis Ritchie. Yeah, and Dennis Ritchie. Sure. It can do so many different types of problems. It's a very generic, reconfigurable. It's like each time you write a program or run a program, you're reconstituting this computer to solve a different problem, and it's doing that all at the same time. It's pretty amazing. People are still obsessed with the jugs. It's pretty cool. So, what are the key elements of a computer? We have the CPU, or a processor, that executes commands. And we have some memory to store the information. That's a very high level discussion of some of the physical components of the computer. Let's look at some of the more of the software stack of what a computer is. Sometimes I call computers machines and people find it weird, but I don't know, get used to it is all I can say. So an operating system is the interface between a user and the hardware of a computer. So right now, I'm running Mac OS, an operating system developed by Apple to run on their hardware. What is an operating system? It's a program, just like the programs you'll be writing. It's a very big program, granted, but it's just a program. It's a set of instructions that tells a CPU what to do. Are you a past student, Felix, from 1531? Anyway, that's an operating system. You might be on a Windows machine, you might be on a phone, you might be on a Linux distro. These are all operating systems. These are all programs written by teams of amazing people that interact. Their job is to interact with the hardware and display some sort of interface to the user. They're very important programs, but they are just programs. In this course, we sort of, I would say, encourage this operating a development environment. I don't know if you necessarily must use it. You probably will use it for certain things, to submit assignments and things. But we will use, and I'll demonstrate this in a moment, a computing environment developed by us at UNSW. Well, not really. We've set it up for you. It's just a Linux machine. So you'll be using and interacting with the Linux operating system a lot in this course. So what is Linux if you've never used it? Well, I would argue that you definitely probably have used Linux. Linux is an operating system developed by Linus Torvalds, which is pretty amazing that he sort of started on his own, but now it's been developed by a lot of different people. And it's a Unix-based operating system, which is open source. It says more reliable. I don't know really what that means, more reliable than what, but it's a reliable, real operating system, very commonly used by developers. It's lightweight. It can run on reduced hardware constraints, and it's, again, I don't know about more secure, but it is secure. All Android phones, for example, are Linux-based, and there's many different computers that you've probably interacted with at some point that are based on a Linux operating system. Other than Linux, then the two big ones are Windows and Mac OS. And the way we interact with, or one of the common ways we interact with these Linux machines or computers in general, is with something like this that you've probably seen before. But in the next few slides, I'm going to break down this alternative sort of paradigm that we have available to us, this very powerful paradigm that we have available to us to interact with these computers. So, who's heard of a terminal? Who uses a terminal in their sort of day-to-day computing? I know I do. I know a lot of the tutors and course admins do, but all of them probably. Yes, Jaden, Joe, Valerie. Who doesn't use one? You've heard of it? Yeah, that's cool. Not day to day. Yeah, you might do it for some things, not often. When you program Discord bots, yeah, that's cool. You've heard of the word terminal? It's like a command prompt. Yeah, it's like a command prompt. If you go back before the Windows operating system, before OS X, if you go way back to, Bell Labs, Brian Koenig and Dennis Ritchie, what computers were these machines, the CPU, and there was no displays connected to them. It was actually a physical printer. I might switch to this. Oh, that's annoying. I need to fix that so that it's meant to be square here. Oh. Okay. They were these machines, right? And then attached to the computer was like a typewriter printer. And you would type on a keyboard and it would physically print like the text that you're typing. And so that when you hit a backspace, for example, I had to like delete the whole, clear the whole line and make a new space. But there were these computers they did not have these displays. And so how do you interact with a computer that doesn't have a display? Well, you use text. And you type text into the keyboard, into the computer, and the computer prints that text out onto physical paper. And this was how humans interacted with computers. Then a few, 5-10 years later, we had CRT machines. And if you're transitioning from this paper-based computing to this CRT machine, what's the first thing that you're going to have? Well, you're going to configure this machine, this CRT display, to display that text that we were previously printing. And so for a few, for many years, a few decades, I think, the primary way these operating systems were built was via interactions via a text-based system. And today we still have this very powerful way of communicating with machines using what we call the terminal. So a terminal is a graphical application. It's a little thing you can drag around and type text into that reads and displays textual information. It allows us to send simple text commands to our shell. It handles things like user input and displaying the shell output. Prison Mike. I don't know what's happening with the chat, but anyway. So what's the shell? The shell is sort of this thing that runs inside of the terminal, or that the terminal can sort of interact with. So the terminal is actually a pretty simple application that just reads the key inputs and knows how to display text. The shell is sort of doing the heavy lifting of the actual execution of commands. So I can use a shell, and I'm going to demonstrate this in a moment, to do lots of things with my computer. I can make files, delete files, move files around, all of that. I can launch applications. That's all executed in the shell. And then, of course, we have the prompt, which is this sort of line of text that tells you some information about, where you are, what you're doing, and lets you sort of respond. And there's a number of shell commands that we can use to interact with our computer. And so what we're going to do now is jump into a demonstration. Okay. Let me open this up like this. All right, so what have I just done? I opened, now all the instructions for this are on the Getting Started page on the 1511 website. But I'm running, you can sort of see here, Tiger VNC. It's an application that lets me access a virtual machine at UNSW, located physically at UNSW. So this is like my personal UNSW machine that I can access anywhere via Tiger VNC. So what I want you all to do, hopefully if you've already set this up, or you can sort of quickly set this up, and Shrey or someone can link the URL to the getting started page. But if you don't have it ready, don't worry, and you can ignore that command there. We're going to link the page to access Tiger VNC. You log in with your ZID and password. In fact, why don't you know what? Let me quit this and let me open it from scratch. So Tiger VNC, I'm just opening this application. This little window pops up. You put in this address. All the information is on the course website. You click connect, and then it just opens this window here. Obviously, you type in your username and password. I use my, okay, don't look at my password. All right, and I log in. I get warned, don't do anything illegal, sure. And then someone asked, what are the resources? So I think it's the same for everyone. 8 gigs of memory, 2 CPU cores, decent. And I get this Debian-based operating system. This is pretty much what you'll see, I think, almost exactly. I haven't actually configured too much. And I mentioned that a terminal is an application, and it's actually already on your sort of dock down here at the bottom. I click it and I get my terminal open. Easy peasy. Why is this really cool? Why do we do this? Why don't you just use your own terminal or the Mac OS terminal or something like that? Well, now what we all have, myself, you, is we have this consistent development environment that's exactly the same for everyone. Now, what you're going to learn very quickly is that I don't work in VLab all that often. How do I zoom in? One of the course admins or tutors is going to tell me. How do I make this bigger? Someone will tell me. Edit preferences font. Appearance. Am I missing something? Oh, there it is. Is 16 going to be too big? Maybe 14? Okay, maybe that's a bit more readable. Okay. Now, cool. So you'll have a terminal just like this. Although yours might not have a black background. I can make this actually a bit bigger. Someone's just telling me. 16. I'll just go 18. It looks pretty good. Okay. I think, yeah. By default, your terminal will look white, and it won't be as configured as nicely with some sort of default settings. What we've gone ahead and done is made a command that you can run. This might be the very first command that you run on a terminal or shell environment, which is so exciting. If you open your CC terminal and you type 1511 setup and you hit enter, mine's not going to do anything because I've already done it. But it's going to apply some sort of other default settings to make it look a bit more like mine. So you just go ahead, you open the terminal, you type 1511 space setup, and you'll see something that changes the environment. And then you can type 1511 colors. We use American spelling when we program, usually. COLORS. I hit enter, and it's changing my terminal to use these colors. And then it does say the next time you open the terminal, you should see some colors. So you would just quit the terminal, reopen it, and you get something that looks a bit more like this. Okay. Now I've got this terminal environment up. I'm going to show you some really basic instructions we can use to interact with the machine. The way I'm going to do this, I'm going to open a directory here. So this is a file explorer. Should look very familiar to use, something used in Windows or Mac OS or whatever. I just have some files here. And you can see that I am in this, there's my ZID right here. That I'm sort of, that's the directory that I'm sort of exploring with this file explorer. And what you can also see here is that my terminal is telling me, my prompt in my terminal is telling me that, hey, this is where I'm located. So just like your file explorer, your terminal has this sort of concept of being located somewhere. And if we look back at our slides, we see we have these commands that we can run. And one of these commands is called ls, list all the files in the current directory. And we're actually going to play around with that. So I'm going to type ls into my terminal, and you can actually see that it's going to list a bunch of files and folders that exist in this directory. Now, if you don't have to be following along, if you just want to watch the content, that's completely fine. But if you are following along, that's also completely fine. Okay. What's interesting here is that if I look at these files, right? So there's a file here. We don't have to worry about what the specifics of the file are, but there is this 22T1 COMP1511 CSV file. There's actually 3 of them. If I look at this file explorer here, there are these CSV files here. So this file explorer and this terminal are actually both pointing to the exact same location. Here's a URL called public HTML, and somewhere here, I'll find a folder, a directory called public HTML. It's got this directory in it called COMP1511. And if I, that is that same sort of directory, public HTML, public HTML. Now, excuse me, in the file explorer, I just double click, we all know this intuitively. I double click on public HTML and I can see what's inside it. I can continue to do that. How do I do this in the terminal? I can't click it, it doesn't work. Remember we said terminals or shells are these text-based systems. So it doesn't really care what I'm clicking on. So I need some way to tell my shell, hey, I actually want to open that directory public HTML. Now we can go back to our slides and see, how do I sort of move the directory or change the directory that I'm working on? Well, nice and helpfully in our slides, we have this example here. How to change the current directory to some other directory. Use the command cd, change directory, and then I give it the name of the directory. So in my file explorer, I would just double click and I would then change my directory to public HTML. Well, how do I do that in a terminal environment? I have to use the change directory command. cd, give it a space, and give it the name of the directory that I want to open. In this case, it's public HTML. So what do? I type it, public _HTML. I hit enter, and what's happened now? It doesn't look like much happened, but something did happen. My prompt has changed. It now ends with public HTML. It's the equivalent of just double clicking public HTML. All right, well, how do I list all the files in public HTML? We know this already. We have the ls command list. When I type ls, what do I see? I see this COMP1511 directory. The same directory I see when I open the folder or the directory in my directory manager, my file manager. And you can sort of keep repeating that. Well, what if I want to open this COMP1511 directory? I can just change the directory into COMP1511. It's case sensitive, keep that in mind. I hit enter. All right, my prompt has changed again. Comp1511 is now the directory listed in my prompt. You will not have the same, sorry, I should mention, you're not going to have the same files that I do, because I've put these files here, right? You're just exploring your operating system, your file directory. Okay, I can actually type the command clear to clear my terminal, so we get a nice blank canvas. And I can type ls again. And now I have two more directories, lecture code and lecture PDF. So you can see I'm just exploring my file system, my directories. All right, what I'm gonna do is change into this lecture code directory. So cd lecture underscore code. I'm gonna check what's here. And I have a bunch of these files, week 1, week 2, week 3, week 4. I'm going to cd into week 1. All right, now I'm in week 1, and I've got 3 files here, program.c, and this other program.c file. Someone's asked, how do you go back one layer? That's a great question, amazing music. There is on the slides, we have, move up one directory, one folder up, cd ... How are you meant to know that? You're not really. It's not very intuitive. You just have to learn it. So if I type change directory ... I will go up one directory, and now you can see I'm back in the previous folder, or I can go cd week 1. All right. I've got these 3 files here. I don't actually want them. I was working on something earlier and I want them deleted. I want them gone. How do I delete these files using my shell? Again, I run a different command that's used to delete files. It's called rm, or remove. So usually these commands sort of try and line up with the command that's being run. And I just type program, I hit enter, I check the files again, and you can see that program has disappeared. I can do the exact same thing, program.c this time. That'll be removed, and then I can remove this last file as well. I hit ls and nothing is there. You notice that I didn't type the full name and then it just auto-completed. If you hit tab, it will try and auto-complete your command for you. But what this means is that I've now deleted all the files in this folder, and we actually have a new directory that I can use from scratch to make some files and do some things like that. Some other commands. I can make a folder or make a directory called makedir, mkdir, give it a name, that'll make a folder. And I can use the command pwd to tell me where the directory structure is that I'm at. So there's some commands there. We even have a helpful cheat sheet on some Unix shell commands. We can copy files, remove files, copy directories. We can do anything we can do with a user interface, we can do via the shell and the command line file operations. And by the end of this course, you're going to be very familiar with these commands. If you remove a file by mistake, is there a way to retrieve it? It probably puts it in the recycle bin, but I'm not too sure. It should be possible. Once you've set up VLab, everyone, you don't download terminal. It's already here included for you. You can just open it that way. But all the instructions on how to get set up are in the course website. Okay. All right, so I've already spoken about CSE's computing resources. That's what VLab is that I've been using. And then you can check out the home computing site for a lot of different guides and things to get started. Okay, so we have about 30 minutes left in the lecture, and we want to actually write a C program. Our very first program. I hope enough of you are able to follow along and do it together. We need a few things to write a program. We need to write the code. We need to write the program. So we need a text editor to write some C code. And I'll show you the text editor that we expect and we will use for COMP1511. We then need to use something called a compiler. We haven't really spoken about what a compiler is, although we'll discuss it. A compiler is just another program that takes some code in a language that we write and turns it into an actual machine-readable program. What it generates is then a program that the machine can run, and we can tell the machine to run that program. And we use VLab to access this editor and this terminal. So I've mentioned a few times C, or the word C, the programming language C. What is C? It's a programming language. It's the language we use to write programs in COMP1511. It's a very low-level language, which is why it's a great choice for a course like this, which is all about teaching you the fundamental concepts of programming. Someone's asked in the chat, Matthew or Matt2 or something, why not just write a language? Why not write the programming code in a language that the computer can read and understand? And it's such an excellent question. Let's talk about it for a moment. Machines are in some ways very simple. Computers are very simple. They understand basically two things, 0 and 1. To write a program at the lowest level, you would need to write zeros and ones. And so then to write anything sophisticated enough would be not humanly possible. There is one step up, which is machine code. So can you write machine code directly? Yes, you absolutely can write machine code or assembler code. And for many decades, that's what programmers did. But it's very explicit. It's, you have to tell the machine very explicitly what to do. It takes a very long time to build anything big enough or sophisticated enough. And what's happened over the years is we've developed these languages that can help generate that machine code much more efficient than we can hand code and at a much better scale. But what's really cool about C is that it's actually very closely mapped to machine code. And the instructions sort of align very well. And it's a really good starting off point for learning how to control a computer from the origins of the C language. Okay. Here is a piece of C code, a very simple program. And we're going to break down sort of line by line what's going on here and then jump in and write this ourselves. So there's a few components of the C program, the C programming language in the text file that we have here. So the first few lines, if we look at this example here, start off with a pair of forward slashes. In the C programming language, it was decided by humans that developed the language that if you have a pair of forward slashes, anything that follows it is what's called a comment. A comment is something for humans and not for the machine. It's completely ignored by the computer, by the machine. In fact, doesn't even get carried over into the program that gets generated. And it's just to communicate something to other programmers or even yourself in the future about what this file is about or what this line is, the preceding line is going to be doing. So what we do in these programs is we say, okay, hey, this program is a little demo program showing off printf in C. It was written by the lecturer in charge in May 2022 that's who wrote this file. I wrote this file. The text editor is actually trying to tell us here that, hey, these are just comments, so I'm not even going to syntax highlight them very well. All right, then we have this include statement. It's necessary sometimes to get pieces of code written by other people that already exist. And the way that we can include code that's written by other people that comes with the C programming language is to use this statement here, hash include space, and then the name of the file that includes some code. So basically it's just like you create some source code. Source code already exists on these machines, included in the C programming language, and we can include that code with this statement. So it asks the compiler to go grab another file of code and add it to ours. In this case, we want the standard input or output library that helps makes text appear on the screen. And almost every C program you write in this course will probably have this line. It's exactly like import in Python. Yeah. All right, and then finally we have the main sort of component of the program that we're going to be writing in the last 15 minutes of the lecture. It might look a bit foreign to you. There's a few things to break down. We'll have a look at it line by line. When I write a program, the machine needs to know where to start executing it. In the C programming language, that always starts executing when it finds this sort of pattern. When it finds a function, so something called main, that's when it actually starts executing that block. What does this block do? Well, the block is indicated by this pair of curly braces, right? So there's two lines inside of the main block. I'll talk a little bit about what this int means in a moment and what this void means in a moment. But what's key here is that we have something called main, and it contains in it these two lines, printf, and then some text, and then return 0. What is printf? In fact, what I'm actually going to do is go back to my editor here. And now I'm actually, if you remember, in my terminal environment, I'm in this week 1 directory. And in my file explorer, I'm also in this week 1 directory. And what I'm actually going to do is write this hello world program. So how do I do that? Well, first of all, I need to make a file that will contain our C programming code. So I'm going to touch the file. It's kind of a weird command, but touch means to make a file. And I'm going to call it hello world.c. When we write C programs, the code needs to be contained or should be contained in a file that ends in the extension .c. What's really cool is that you can see when I created this file, it immediately appeared in my file explorer. Okay, now I need to open this file in my text editor. In this course, there's lots of different text editors you can use. In this course, I'm using an editor called gedit. It comes in, it's sort of packaged in this environment for you. Now, I could just open gedit here, but I actually need to tell gedit what file I want to be editing. And what file do I want to be editing? It's this hello world.c file. If we list the files available to us, we can see that there's this hello world.c file, which means I can type gedit hello_world.c. And something we can do or should do is put an ampersand at the end. And I'll explain a little bit about what that does, but you don't really have to do it or worry about it. But I hit enter. And well, what's it gone off and done? It's opened gedit, that's what this is, a text editor, and it's opened hello world.c. An empty text file, right? Because I just created it with nothing in it. So you can see that, like when you double click on a file or you double click on a program, all the ways we can interact with this computer, I can do via the shell in the terminal. And what I'm going to do here, yeah, gedit is explained, is contained, in VLab. And what I'm going to do in this hello world.c file is write our very first C program. Okay. The first thing we need to do is write out our sort of header comment that explains what the aim of this program is. So a C program to display the text hello world. Now, what the ampersand is meant to do is open the text file, but not lock up my terminal. But sometimes it doesn't actually do that all too well. So I think what you can just do is hit Control-C on your keyboard, and it will actually sort of fix up and reset my terminal. I don't know why it does this. It's a bug in gedit, I actually think. You can ignore, what I'm trying to say is you can ignore this warning. But what we want is the terminal looking something like this. And we get our file looking something like this. So I wrote 2 forward slashes, which denotes, hey, what I'm typing is a comment. I'm going to say written by Jake Renzella, May 2022. Right, so this is, you don't have to do this. It's a comment, right? So it's completely ignored by the machine. But I'm communicating to future readers of this C program that who wrote it and what I was trying to do in this program. Now, where does a program begin? In C, the computer will start executing the program at the main function. So that means I have to make the main function. What syntax do I, and again, I might want to just zoom in a bit here too, don't I? No, I can't. There we go. That's a bit better, maybe. Is that readable, everyone? So I have to create the main function. So this function must be called MAIN. It has to be called MAIN. That's how the computer knows, the machine knows where to start executing this program. Now, functions always contain followed, so you have the name of the function followed by a pair of braces. And in those pair of braces, what we want to say is that we can put the term void here. Now, void's a bit of a weird concept in C. Void basically means nothing. So it sort of means I'm not accepting any information. It'll make a bit more sense when we talk about functions in a bit more detail. Okay, so the main function is a special function, as Amazing Music has pointed out. We can't have another main function anywhere else because that would sort of mean that, oh, I have these two, you can't have 2 starting points, right? So you have to have main there. Yeah, if some of you have programmed before in C or C++, you've probably just seen this. It's exactly the same as not putting anything in the brackets there. So this would work and this would also work. What we're doing here is being a bit more explicit by saying, yeah, I don't expect anything to come here. Then I need to say, well, you know, how do I know what belongs to main and what doesn't belong to main? Well, I need to use these curly braces to sort of tell the computer or tell the machine where main begins and where it ends. So this is like a container. We call it a block in programming. It's the block of code that's going to execute when we call the main function. Okay, now I hit the tab button because we want to say that what I'm typing here is contained in this main function. And what I want this program to do is display the text hello world with an exclamation mark. Why are we doing hello world? Hello world is the first program you should always write when you pick up a new programming language. Otherwise, the programming gods will smite you forever. How do I print text in C? We use a function designed to print text to the terminal. And that function in C is called printf, or a printer formatted string. That's what the F stands for. And like main, excuse me, like main is a function that accepts nothing, or the void. Print is a function that expects some text. How do I discern text from things like functions, these identifiers? Well, in the C programming language, we use a pair of double quotes to indicate that, hey, what's contained in this in these quotes is a string. And you can see gedit is going to highlight those in pink. So if I want to print the string hello world, what do I need to put in these double quotes? I need to put, hello world. HELLO world. And I can put anything I want in this string, sort of any text. I'm going to leave it at there for now. In C, when we end a line, we have to put a semicolon. Okay, that tells the computer, hey, I want to print this string, and that's all I want to do. All right, this looks right, doesn't it? So I've got a print command, I'm calling it. I've got some double quotes, some quotation marks. And what's in the quotation marks is hello world. That's roughly what I wanted to print, so I'm pretty happy with that. We need to now turn this program into machine readable code. At the moment, all we've got is this C file. So what I want to do then is save this file. So save the changes to this hello world.c file. Saving is really important. So I can go File, hit Save, or just hit Control S, and you can see now that the editor is telling me, yeah, you've gone ahead and saved this file. Is there a command for viewing the contents of a file in Unix? No one asked, but I'm going to answer anyway. Yes, there is. It's called cat, C-A-T, and then I can give it the name hello world.c. And you can see when I run this command, it actually tells me, hey, yeah, I can actually see what you saved. It's showing up in this file. That's really good. So that's a nice little helpful way to make sure you've saved the file in the right location. Okay. What I want to do now is convert this. So the computer cannot execute this C file. This C file is human readable instructions that is in a language designed for humans. The machine, the computer cannot understand or execute this language. So we need to use a tool, right? Another program designed to take this human readable C code and convert it to a machine executable program. I'm going to clear my terminal and I'm going to call this special program, this very important program called a compiler. The compiler we're going to be using is called DCC. This is a compiler based off the GCC compiler or the GNU C compiler. And I have to give it a few pieces of information so that it can do this. I need to give it the name of the file that I want to compile. In this case, it's called hello world.c. Now I can't just hit enter here. I need to give it a few more pieces of information. Remember I said I want to take this C file and convert it into a new file that contains machine readable code or instructions. The way I indicate that to DCC is by using this -O. And then what follows the -O is just the name of the program that I want to be executing. I'm going to call it program. Let's just call it program. So let's run through this quickly. I know we've only got 5 minutes left. Run the compiler on this C file that we just wrote together and output the file to a new file called program. When I hit enter, it's going to go off and try and do that. And you can see it actually did it. There's this new file called program that got generated. How cool. Now, the compiler is designed to help us write good code. It's actually giving us a warning here. Hey, it's kind of hard to understand. You're implicitly declaring a library function printf. The compiler, DCC, is actually telling us, hey, Jake, I think you've maybe made a mistake here. You've made a function, you've called a function that's actually a library function. That's kind of weird. And if we look back, it's kind of right. If we look at the program we were meant to write that I had on the slides, I spoke about that we have to include these library functions like printf. What the compiler is telling me is that, Jake, I think you've made a mistake maybe because printf actually, you didn't write printf, Jake, which is true. I did not write printf. Printf comes from the standard input-output library, but you didn't include it. You didn't include it. So it's actually trying to help me and tell me that, hey, Jake, you didn't include it. So I can include it. Standard input-output .h. Okay. And I can hit save. And I can go up. I press the up key on my keyboard, and that brings up the previously executed command. And I hit enter, and and look at that. It compiled the program without the warning. So the compiler here, not only is it turning our programs into machine executable programs or instructions, it's actually doing a second job, which is to help us write code without errors. Isn't that amazing? So some human wrote a program called DCC that does all of these amazing things by converting these programs into these machine readable programs, and also at the same time give us warnings or errors if it thinks we've made a mistake along the way. Now, if you look back at the example code I gave, there's a few things missing. I don't have this return 0. What is return 0? Return 0 is basically something we sort of do and don't need to go over, but basically when I run the main function, what we're saying is that, hey, you need to return an integer. We're going to talk about what an integer is tomorrow, but the program wants to know, hey, did I finish successfully? And the way we communicate that in the main function in C is by returning the number 0. How are you meant to know this? You're sort of not. It's just a conceptual agreement we've all made, programmers have made with each other that says if we return 0, the program completed successfully. Now, if I were to run this program that I just executed right now, is it going to return 0 or not? What does the chat think? Now, Jaden, you could put any number there, but any other number other than 0 indicates that there was an error with the program. In this case, we don't expect an error has occurred if we get up to line 8. Therefore, we're happy to return 0. But I don't want you to focus on it too much just yet. And the chat, you're pretty much right. It's not going to. Why is it not going to return 0 yet? Well, I saved my C program, but I did not compile it into this program executable here. So I saved the file, but I need to press up on my keyboard one more time, compile it again, and now it will override that program with a new version that has my updated changes. Leo asked, why do we not include standard IO? I have on line 4 just there. I have saved the file but after saving the file, you have to compile it again. I guarantee you, many of you are going to make this mistake. You'll write some C code, you'll run the program, it won't do what you expected, you'll think you made an error. Actually, you never compiled it, and you ran a previous version. Okay, it's 11 o'clock, but we're going to go a few minutes over, that's okay. We wrote some C programming language code. We generated this thing called program. I want to run this program. How do I do that? Really complicated, right? I just type the name of the program that I generated. And you can see it's actually made it green because it knows that this is actually something that's executable. It knows that program is a thing that it can execute, and it knows that hello world.c is not a thing it can execute. So it highlights program in green. How do I execute program? I run the name of the file that the computer can program. And when I hit enter, nope, never mind. I have to tell it, look for the program file in this current directory with the period here. So this is maybe another mistake that lots of us will make. And so look in the current directory and execute the file called program. Look at that. What do we see here? Can you catch that? Hello world got printed. Why did it print hello world? I told it, hey, print hello world. Isn't that amazing? We just wrote a C program we told it to print something, we compiled the program, we ran the program, and it did what we told it to do. Now, you might notice this looks a bit funky. Why is it put hello world and then it's put the prompt right after it? That doesn't look good. I don't want that. And this is what's also missing from our slide. We had this \n. What does \n do? It's a special sequence that says, hey, print out hello world, and then print out a new line. That's what the N stands for, \n, new line. What do? I need to, quickly, what are the steps I need to do? I need to save this file, to update the C code in the computer. I can't just run it again because I didn't recompile it. I didn't generate a new version of the program. How do I do that? I need to run the compiler. I can just hit the up key in my terminal a few times to go back to the command I want to execute. I'm going to convert that hello world.c file into and override the existing program. So save, then compile. Exactly right, Zoe. I hit up again. How do I execute program? I execute program. And you can see that looks a bit different. It's put a new line after hello world. And we have successfully written our first program. It doesn't matter if it was my first time programming or if I picked up a new programming language tomorrow, the first program I write in any language, and we all do, all of us programmers do, is write hello world. And that's what we've done today. Isn't this exciting? We have managed to wrangle this beast of a machine. We have written some instructions in a human readable language. You might not think it's human readable, but you will get there. We turned that human readable language into a machine readable program called program. Why is it called program? I told it to call it program. This is the key here. Computers are dumb. I know you think that they're amazing smart machines, AI, machine learning, self-driving. Computers are really unintelligent. They only do exactly what we tell them to do. I told this computer to generate a program called program. I know, very creative. And when I ran that program, it did exactly what I told the machine to do, which was to print hello world. To finish off the first lecture, I'm going to just simply edit what I'm printing instead of saying hello world. And I'm going to link us back to what we started the lecture. Who can remember what the title of the lecture screen was when I started the stream? It was welcome. It was something like welcome to the beginning. I'll put a new line there. Welcome everyone. Welcome to the beginning of COMP1511. I save the file. I compile the program. I execute the program, and that's where we're going to leave. I probably misspelled it there. Yep, there's only one N. Spelling isn't our, I compile the program, I run the program, and I finish our first lecture together, welcoming you to COMP1511, welcoming you to writing our first C programs. Tiny Lad says we should just say bye and end the lecture. I see it as we're starting off the next 10 weeks together. So welcome. Go ahead and follow this lecture yourself, and follow in your tutorial this week. You'll also write these programs. We're going to help you along the way. Yeah, I'll see you all later. See you later. Thank you all for coming for the first lecture. I'll see you tomorrow. And if you all do very well, I'll share my keyboard details. See you tomorrow in the afternoon. Bye, everyone.